Welcome back to section 1.1, part 2, and we'll continue where we left off.
So if we head back to analyzing data, there are some potential pitfalls that can happen. Here are a few of them, and we'll go into them in more detail. So misleading conclusions. When forming a conclusion, we should make statements that are clear even to people who do not have any understanding of statistics and terminology. And we also have to be careful that just because things are associated or correlated, as we'll talk about later, doesn't necessarily mean that one causes the other. So if we go back to the boats and the manatees, a statistical analysis might justify that there is a correlation between the number of boats and the number of manatee fatalities. They both increase at the same time. One's increasing, the other's increasing. But we don't really have enough to say that an increase in the number of boats causes an increase in the number of manatee fatalities just based on the evidence that we have. So we have to be careful that just because things are correlated does not imply that they have causation. Another is sample data that's reported instead of measured. When collecting data from subjects or people, it's better to take measurements yourself instead of asking subjects to report results. Here's an easy example. If you think about asking people how much they weigh, most people are not going to be honest about how much they weigh, so it's better to maybe show up with a scale and measure it yourself. Loaded questions. I hope that as you hear these analyzing data opportunities and you start seeing statistics around you, you start to notice where these are happening. So these are loaded questions where the wording is a little misleading. So take a look at this example here, and then as you watch the news, read the news, or consume statistics around us, think about if the questions being asked are misleading or loaded. Sometimes even just the order of the questions, and this could be unintentionally loaded, but if we ask, would you say traffic consumes more or less to air pollution than industry? But if we switch it to say, what about industry contributing more or less? People are more likely to respond to the first thing they hear, and so we have to be mindful about the order of the questions. Another example is non-response. A non-response occurs when someone either refuses to respond or are just unavailable. In this book, Michael Wheeler says the following here, which is basically just who are the people that are likely to talk to pollsters and people who are not likely, and how does that affect the sample information that we're getting? And percentages. Some studies cite misleading percentages. This is really important. You hear all the time, 100% is everything. You can't have a percentage that exceeds 100%. So in this example, they say the club, a device used to discourage car thefts, it stated that it reduces your odds of car theft by 400%. But if the club eliminated all car thefts, it would reduce it by 100%. The figure 400% is misleading and doesn't make any sense. And you'll notice that that is used a lot in advertising. So using these potential pitfalls, go ahead and give these 3 problems a try and press play when you're ready to see the answers. And here you go. Lastly, we're just going to conclude with some percentages, fractions, and decimals, just to make sure that we're all on the same page here. So to find the percentage of an amount, there's 2 ways that you can do it. So one way is this calculation called is over of equals percent over 100. And you can kind of play around with the is or the of. So I'll do this here. So 6%, so there's our percent, of 1,200, so we'll put 1,200 there, is 72. So it was saying 72 over over 1,200 is equal to 6 over 100. Another way is to use of as a multiplication. Of is multiplication. So we have to turn it into a decimal, which we'll talk about in a moment. But 6% of 1,200. 6% of 1,200. If we think of as multiplication, and 6%, we're going to change that to a decimal. We can divide that by 100. Or we can move the decimal over to the left twice. So we get 0.06 times 1,200. We'll get 72. Now, if you'd like to change a decimal to a percent, you multiply by 100. So before we divided to change the percent, to get a decimal to a percent, we multiply. And so if we have 0.25 and we want to make it a percent, we can multiply by 100, or you can move the decimal over twice. Why twice? 2 zeros. So it becomes 25%. Two more examples here. If you've got a fraction and you're trying to convert it into a percentage, you would divide the numerator by the denominator. So we would type into our calculator 3 divided by 4, and we would get a decimal 0.75. You could multiply that by 100, or you could take 0.75 and move it over twice and get 75%. To convert from a percentage to a decimal, you would just divide by 100, which we did earlier. So if we've got 85%, we could say that's equal to 85 over 100. Or we can take that decimal, it's invisible, but it's there, and move it backwards too and get 0.85. So go ahead and give these percentages a try. And there are the solutions. And that concludes section 1.1.